right, let's talk about calculating the volume of shapes. We've got some basic formulas here. Now you can refer back to our notes packet to see which formulas you need to have memorized and which of them would be given to you on a test. We've got our rectangular prism, or this could also be a cube. Now we have written down here for this guy that it is the volume is the length times the width times the height. Now you see that's slightly different from the formula here because that capital B right there stands for base. So my capital B is the length times the width. Let's see, that capital B right there is the area of the base. That's why it's a capital B there. So you can see it kind of highlighted here. The area of that is length times width, and then we have to multiply it times height because volume is three-dimensional, length, width, and height. That's why all of our units are centimeters cubed, because they're centimeters for the length times centimeters for the width times centimeters for the height. So 3 centimeters multiplied gives me centimeters cubed. Now a right pyramid takes up 1/3 of a prism. So if you could imagine picking this shape up and plopping it down inside of there, it would take up 1/3 of the space. So it's 1/3, and then again, that B right there is the area of the base. So the capital B should have two different variables in it. So again, this is a square, so it would be length times width. And then 1/3, because it takes up 1/3 of the space, in the height. Do note that I am using H here, and specifically on this one. So we want to use the height, not the lateral height. Remember, the lateral height is the one that's on this outside right here. This guy would be the lateral height, and we only use that for surface area. Here's my cylinder. Again, the area of the base is pi r squared. So it's pi r squared H. So pi r squared times height. You can kind of imagine in your head, you know, when you do hole punches and you get the little circle things out of them, eventually you have to throw them away. It's a circle stacked on top of each other. It's a whole bunch of circles. Or think about a Ritz cracker. You have and they're not exactly flat, but you have a cracker, and then you keep stacking them on top of each other and you get a cylinder out of it. So you have the area of your cracker and then multiple crackers on top of it. For the cone, again, there's that 1/3 that comes from, if you were to take this cone and stick it inside the cylinder, it takes up 1/3 of the space. So it's 1/3. The base is pi r squared H. So because the circle base is pi r squared. Here we have that rectangular prism just written again, how we're used to kind of seeing length times width times height. All right, so let's try a problem down here. So we want to find the volume of a square pyramid with base length 6 centimeters and a lateral height of 5 centimeters. So a square pyramid has a square for a base, and they told me that both is a square, so the same on each side, is 6 times 6. So the area of this base is 6 times 6. So I'm using my formula up here is 1/3 area of the base H. So right here is 1/3 capital B times capital B, that's the area of the base, times the height. Well, I know that capital B is 6 times 6 because that's the area of the base, 6 times 6. Now I need to find H. I was not given H. I was given the lateral height. That's what I would use for the surface area. I need to find the regular height. So we're going to go back to our Pythagorean theorem that we used before to solve for L. So remember, the lateral height is always my hypotenuse. So I know that it's going to be a squared plus b squared equals c squared, and that c is going to be 5 squared. Now I need to make that right triangle with the lateral height. So I'm going to come back up here. Remember, the lateral height is this guy on the outside. So I need to make the perpendicular bisector. I know that's not a great looking triangle there. The perpendicular bisector cuts that base in half. So my problem all the way across was 6. Halfway across is 3. So that's going to be my A, 3 squared. And I'm looking for the other side. So I'm going to be looking for B squared. Again, up here, I've got 3 right there. And I told you the lateral height was 5. So we're looking for this height right there. If you want to call it H instead of B, go for it. You can call it X, doesn't matter to me. If you know your triples, you already know what the answer is going to be. You don't need to show that work, that's fine. But if you don't know your triples, that's okay. 3 squared is 9, and 5 squared is 25. I'm just going to solve this for B squared, so I'm going to subtract 9 from both sides. That gives me B squared equals 16. To get that square root, that square by itself, I'm going to take the square root of both sides. So I'm going to take the square root of both of these. That cancels that square out. So I'm left with B is equal to 4. Now, if you're going to get confused because of that B and this capital B, again, you can call it something else if you want to. So the height, coming back up here to my text box that I had right there, my height is 4. So that's going to give me 48, and we're going to do cubed, or centimeters cubed. I'll move this over so we can see a little bit better. So this B right here was my actual height, not my lateral height.